All right. So now let's talk about the second part of our decision-making problem, affordability, and it's depicted here by a budget constraint. So the budget constraint is px times x plus py times y equal I. What does that mean? It means that you have an income I, which is assumed to be spent on X and Y. So we spend everything on X and Y so that the amount of money we spend on X, which is price times quantity, and the amount of money we spend on Y must sum up exactly to I. That's the idea here. To put it in the graph, we need an equation for the budget line. What is that? It's just simply you write one good as a function of the others and all the prices and income. So let's say we want to derive a function y of x and the prices and income. First thing, we need to put something without y to the other side of the equation. So that means, let's write it, py times y equal to I minus px times x. And then we divide both sides for py to have a function of y. Pretty simple. Py minus px over over py times x. And this is the budget line equation. No? Now, we already got the budget line equations. What is each element in it? So we have the intercept, which is I over py. And then you have the slope. Do you remember what the slope is? The slope is the derivative of y with respect to x, and it tells us how y changes when x changes, right? So that's the derivative. In this case, it's a linear function, so only one x there's gone, so minus px over py, right? So that's the slope. Technically, you have the intercept, you have the slope, you can draw the lines. But here, let's do something more primary so that we also can see some more information. So now we need 2 points to draw the lines. The first point is, let's say we set x equal to 0. Then we have y equal to I over py. What is that? That is the point where you don't consume any x at all and you put all the money you have on y. That is the intercept. So x is 0 and y is I over py. So now let's do the second point. Set x equal to, sorry, not x, but y equal to 0. Then x equal to, let's look at it here, right here. So if here you have y equal to 0, then the term on the right-hand side, the left-hand side is 0. And then you put I to the other side. At the end, you will have x equal to I over px. Similar to before, this is the point where you don't consume any y and you put on the money on x. So when you connect these 2 points, you will have the budget line. That's it. Now, how the line will move when either px or py changes. Let's see. The first cases where we have px increases. So what does that mean? That means that the intercept remain unchanged. However, the slope gets steeper or more negative, and the maximal affordable quantity of x will drop. Why is that the case? Let's see. Imagine, so now we have px prime larger than px because it increased. So that would mean the first thing is I over py, same as before. So that intercept stay the same. The second thing, because we have px prime larger than px, so we have px prime over py larger than px over py, right? And that means minus px prime over py is smaller or more negative than minus px over py. So that's why the slope get more negative and the curve becomes steeper. And we also have the maximal affordability of quantity of x, which is, I, but now over px prime is smaller. Px prime is smaller than I over px, right? So that is the reason why the maximum quantity of x that we could consume without any money on y is smaller now. So consequently, the new budget line will look like this. We can do it in a similar manner for the case of py increases. So in this case, if py increases, intercept changes because there is py in the intercept. The slope less steep and the maximum affordable quantity of y drops. How exactly does that work? Let's see. So now you have, first let's look at the intercept. So let's put it here. So we have py prime larger than py, right? So intercept I over py prime will be smaller than I over py. Price increase, you can buy less. All right. And the second thing with the slope. So you have step by step, px over py prime will be smaller than px over py because py prime is larger than py. So one step further, that means minus px over py prime will be larger or less negative than minus px over py. All right, so that's why the slope less steeper, and the maximum affordable quantity of y, which is exactly this one, the intercept, drops. And consequently, we have this kind of change or shift inward of the budget line. Yeah. Now, what if income changes? Either we have an increase or decreases income. What would happen? So let's say we have income increases, which is I1 larger than I. So now the budget line will become y equal to I1 over py minus px over py times x. Let's look at it. So the slope remains the same, right? So there's no change in the steepness of the curve. It will be the same sloping level. And then we have the intercept is something changing here. We have I1 over py, py is larger than I over py. So the intercept will move upward. And then we also have the point where everything spent on x, which is I over px, larger than I over px. So that would be a parallel shift away from the origin or to the right hand side. So the maximum affordable quantities of x and y also increases, like shown here, by the same percentage, like proportionally, and the slope remain unchanged. See, that is the result, like we just said. And now, what if we have all prices changes at the same factor? So if we multiply all prices by the factor t larger than 0, what will happen? The budget line will become y equal to I over t py, because we multiply it with t, minus t px over t py times x. So these two t's cancel out, and here we will have I over tpy minus px over py times x. So we rearrange it a bit and put t on the numerator. So that will be y equals I over t over py here, and minus px over py times x. So here the result implies two things. The first thing is if all prices change or increase by the same factor t, then the budget line will shift to the left and the intercept will decrease by a factor t. The second thing, writing it this way, you can see that similar to the case where we have income reduced by a factor t. So those two scenarios equivalent. Either you increase all prices by t, or you decrease income by t times. They will lead to the same result. Now, let's combine those two together. What if prices, all prices, and income increase or decrease at the same time by a factor t. What will happen? Let's see it here. We have the budget line will become I times t, because it's increased by t time now, over by, also times t, right? And then minus px times t over py, also times t, and then times x. And all those t's are cancelled out. So still at the end, we have I over py minus px over py, which is exactly the same as before. The budget lines will remain unchanged, right? One example you could think about is when your income, let's say your salary increases by 5%, so times 1.05. And then at the same time, there's also an inflation of 5%. So all prices of goods, commodities increase also by 1.05 times. And in that case, nothing changed. You still can buy the same amount of goods as before. Your purchasing power is not changed.